horizontal axis. The categories being studied, as you see a little further down there, I didn't have, like, name of food or brand of food or whatever. So anyways, a bar graph is a diagram in which data about separate but related items are represented by rectangular shapes called bars. So that's easy. You usually place the categories being studied on the horizontal axis. Horizontal meaning, I remember it by horizon, so that'd be along the bottom. It's also known as the x-axis. Place the measurement or amount on the vertical axis. The measurement for each category is represented by a separate bar. The length of the bar indicates the amount of the measurement. So, this would be an example, and you can see on the vertical axis and is lacking weight after food. And then the horizontal axis is lacking brand of food. Then a note is bar graphs cater to visual learners, because really what bar graphs really want to do is give you something to look at other than numbers. So obviously bar graphs would cater to visual learners. Now this is a different experiment we did called Tom's soil experiment. Tom wants to see whether more water drains out of sandy soil, clay soil, or rocky soil. Now, I copied and pasted this, obviously. Pretend the rocky soil is not there. He buys, because it won't be part of the experiment. Anyway, he buys 2 of the same hanging planter pots from Lowe's. Each pot has 5 holes on the bottom. Tom hangs each planter pot on his back porch in the sun, and he puts a bucket under each pot. And you see each. They have to, these controlled variables have to be the same for both, or it won't be a fair experiment. Tom places 2 kilograms of clay soil in one pot and 2 kilograms of sandy soil in another pot. He then pours 1,000 milliliters of water into each pot. He measures and records the amount of water in milliliters that has drained through the soil and collected in each pot after 2 minutes. He measures the amounts again when it's been a total of 4 minutes. So the data tables and graphs you will be seeing, or not the data tables, but the graph will only be for the 2 minute thing. It won't be for the full 4 minutes. It'll only be for 2. So Tom's soil experiment continued. After 2 minutes, 275 milliliters collected under the sandy soil planter and 150 milliliters collected under the clay soil planter after 2 minutes. So that basically just tells you right there that the clay soil holds in more water. So I guess preferably that would be the better soil. After 4 minutes, you don't really have to know that, but you can look at it. 500 milliliters collected under the sandy soil and 210 milliliters collected under the clay soil. So see in the next 2 pages for a good bar graph representation. Actually, not next 2 pages, just the next page. Effects of soil on drainage. And you can just see right there. That's basically how it's supposed to look, but again, some fatal flaws. For the sandy and clay, beneath that, in the middle would be type of soil, and then from 0 to 300, you should put drainage in milliliters or ml. Now, this is again a different experiment. This was a bonus experiment. You didn't have to do it. It wasn't a bonus experiment, but it was an experiment that you could just do for extra practice. Sally and Sammy's diet bar experiment. Sally and Sammy are identical twin women who are 30 years old. So they're identical twins, completely identical. They both want to lose some weight, and I mean they're 141 pounds, as you can see in the next representation. But you know, they want to lose weight even more. So they both want to lose some weight, and they want to try diet bars. Each day for 7 days, the women eat 2 cups of oatmeal for breakfast, 2 apples as snacks, a diet bar for lunch, and the diet bar is obviously the most important, and grilled chicken and vegetables for dinner. However, they want to see which diet bar is better, Diet Pro or Yummy Diet. For So for lunch, Sally has a Diet Pro bar and Sammy has the Yummy Diet bar. They weigh themselves in kilograms each day for the week. They want to determine who has lost the most weight by the end of the 7 days. The twins have similar metabolisms and activity levels, and both exercise by going on a 30-minute walk every day. So, 2 questions. What is the manipulated variable in this experiment? The kind of diet bar the twins have is the manipulated variable in this experiment. What is the responding variable in this experiment? The responding variable is the weight of the twins after eating diet bars for a week. Here are the diet bar results. Like I said, they're still pretty skinny, but they got even skinnier. The diet bar results are Sally's diary. I just call it a diary. Sally started the experiment weighing 64 kilograms on day 1, 141 pounds. On day 2, Sally weighed 63.7, so she's losing some weight. Day 3 was 63.5. These are all in kilograms, by the way, so I don't have to keep saying it. Day 4, 63 kilograms flat. Day 5, 63 flat. Day 6, 62.8. Day 7, which is the end of the week, 62.5. Sammy's diary. Sammy started the experiment weighing 63 kilograms on day 1. On day 2, Sammy weighed 62.7 kilograms. Day 3 was 62.6 kilograms. Day 4, 62.3. Day 5, 62.3. Day 6, just 62 flat. Day 7, 61.9. So Sammy remained the lightest, but what was the better diet bar? What do you think? I'll let you spend a little bit of time reviewing that and trying to calculate. What was the better bar? What made these women lose the most weight? Which bar? Yummy Diet or Diet Pro? Diet Pro is the better bar. So you probably calculated that pretty easily. So who takes the bride? Sammy remains the lightest, but Sally loses the most weight with Diet Pro. So Sally's total weight loss 1.5 kilograms. Sammy's total weight loss 1.1 kilograms. So Diet Bar, the best bar. Better than Yummy Bar. So that's how that experiment went. Now we're going to move on to not so much an experiment, but some notes that you should probably take on the metric system. The metric system is based off tens. Some definitions here. Mass equals how much matter is in an object. Grams, abbreviated by lowercase g, is the base unit mass. So, you don't use pounds, you use grams. It's metric system. Metric system is basically what everyone uses, except the United States and a couple other select countries. I think Canada even uses the metric system. Kilograms is 1,000 grams, so it's 1,000 times bigger than 1 gram. A kilogram is. Milligrams are 1/1000th of a gram, so they're 1,000 times smaller than a gram, so very, very small. Volume is the space an object takes up, so basically like the size. It's similar to the size. Liter, which is abbreviated capital L, base unit of liquid volume, and a milliliter. And I don't know why it's abbreviated like that, but it's lowercase m, uppercase L, equals 1/1000th of a liter. So, kind of like the same as milligrams to kilograms, milliliter to liter. So, milligrams to grams and milliliter to liter. Rulers and temperature probes. Rulers measure distance. We will measure in centimeters. Meter is base unit. 100 centimeters equal 1 meter. Always measure to the nearest tenth of a centimeter, so don't measure to let's say 61.468205. Just measure to, let's just say 6.10 or 6.1. Always use degrees Celsius, so never use degrees Fahrenheit, because we're learning in 7th grade science the metric system, not the American system. So, Fahrenheit is the American way of doing things. The metric system uses Celsius.